Let us talk about neural networks. Neural networks, also known as artificial neural networks or simulated neural networks, are a subset of machine learning and are at the heart of deep learning algorithms. Their name and structure are inspired by the human brain, mimicking the way that biological neurons signal to one another. Artificial neural networks are composed of node layers containing an input layer, one or more hidden layers, and an output layer. Each node or artificial neuron connects to another and has an associated weight and threshold. If the output of any individual node is above the specified threshold value, that node is activated, sending the data to the next layer of the network. For calculating the number of parameters in the given diagram, we have 4 neurons in the hidden layer, each receiving signals from 3 input layers, then the 2 output layers, each receiving signals from 4 hidden layers. Thus, we get 20 weights and 6 biases of the hidden layer and output layer, resulting in a total of 26 parameters for this network. Weights are the predefined for each input neuron as well as their activation function. Bias is a threshold value over which a neuron activates. So, output of a single neuron is based upon the weighted sum of activation levels of all the neurons. The rectified linear activation function is a piecewise linear function that will output the input directly if it is positive. Otherwise, it will output 0. It has become the default activation function for many types of neural networks because a model that uses it is easier to train and often achieves better performance.
Now, as we all know, we need to train ourselves to achieve better performance. Similarly, machines are not an exception. Neural networks are needed to be trained in order to achieve more accurate predictions. When the information is passed from the input to the output layers, this system is known as forward feed neural network. After we get the output, it is checked with the actual desired output and the error is noted. To reduce the error, signal now travels back into the network from the output and alters the parameters of each neuron with the help of another algorithm known as gradient descent. This backward traveling of signals within the neuron is known as backward propagation algorithm. Now suppose we have a dataset of 10,000 items. The modifications in a single data value has to be repeated over the entire dataset. This is referred to as one epoch. With each epoch, we gradually decrease the error levels of the model, and after a certain time, the drop in error level will seem to be insignificant. Think about performing 5 epochs over the given dataset. Number of parameters in the neural network is 46. Hence, the total number of calculations required is 23 lakhs, which is a huge and it takes significant amount of time to train the model. Thankfully, models once trained can be stored and need not be trained again. Hyperparameters help us to fine-tune our models. We should decide wisely about the other parameters to get a better prediction. For example, number of hidden layers can be reduced to overcome overfitting, or the number of epochs can be decided to find out optimum balance between the time required to train the model versus relative rise in accuracy of prediction. Finally, frameworks that help us to execute our codes. Actually, we execute our codes over APIs. For example, when you drive a car, you press the accelerator and the car speeds up. You change the gears and your car runs smoothly. There's something going on inside, but we are not bothered by those things. So we basically use 2 popular frameworks, namely TensorFlow for backend and Keras for frontend. The content of this presentation is derived from this book. The book is written in a friendly manner for beginners to get them started. Link to the book is given in the description along with the other videos of the series. Thank you.